Hello everyone, welcome to the lecture series of Theory of Computation. In this video we'll learn about regular expressions. So to understand regular expressions, let's take a real life example of email ID validation. Email ID validation. So to understand regular expression, think of how websites check if the email you enter is valid or not when you sign up for any website or even your Gmail account. So they don't manually check each character, right? Instead they use regular expressions to define a pattern that a valid email ID should follow. If the email ID is valid, then it should be according to that pattern, and there is a regular expression to define that pattern. Now, for example, let's say a valid email ID. What all things valid email ID should contain? A valid email must have characters, right? It can have letters, it can have numbers, and it can have underscore also. It can even have a dot also before @ is encountered, right? So this is one of the rule. The second rule says then @ should be there. The third rule says then a domain name will be there, like whether it's a Gmail account or a Yahoo email ID. Then a domain name which tells us about whether it's Gmail or whether it's Yahoo. Then finally a dot will be followed by either .com or .org or .in, basically the domain extension. So this all can be represented as a regular expression. We can write like before @, it can have either uppercase letters, it can have lowercase letters, it can have digits. Then @, then to define domain name, it can even use the lowercase letters, then dot, and this .com, .org again lowercase letters will be used. So whenever you type any email ID, let's say I type student123 @gmail.com, right? So this is according to this pattern, this regular expression. So we say that this is a valid email ID and it is accepted. But if I type something like hello @abc, then this is not according to this pattern and we say that this email ID is rejected, right? So just like we use grammar rules in English to check whether a sentence is correct or not, similarly we use regular expressions in TUC to define rules for the strings that can belong to a language. So regular expression is basically another way of defining our languages. So till now we have seen the use of clean star, that is applied directly to a set. Like we have seen, if my alphabet is S consisting of AB symbols, then S star defines the clean closure of this set. Similarly, we have also seen if the alphabet is represented like this symbol, then we can use the clean star to represent the clean closure of this particular alphabet. Now we introduce the use of clean star or the plus, or that is the positive closure, applied not to a set but directly to the letters or the symbols of the alphabet, right? So if I write like X star, so what does this indicate? This indicates sequence of X's. The terminology of star and plus remains same. The only difference is now we are applying to the symbols of the alphabet instead of the alphabet. Right? So X star represents sequence of X's. So this can be represented as X star, can be represented, it can have either lambda since it's a star, or it can have single x, or x square, or x cube, or x to the power 4, and so on. So we can also represent this X star as nothing but x raised to the power n, where the power of n can be from 0, 1, 2, 3 and so on, right? So this is my regular expression. Now we can also define the language defined by this regular expression. So how to define the language defined by this regular expression? Language of the regular expression X star defines all possible strings of x's of any length, right? This is what the language defines. Similarly, let's take another example. If I write alphabet as AB, right? And my language is, let's say A, AB, AB, A triple B. These are the strings belonging to my language, right? And so on. So if we carefully look at the language, we can see either it consists of a single A, or after a single A, there is any number of B's. Here it is having 0 B's, here 1 B, here 2 B, here 3 B's, here 4 B's, and so on. So basically the language of this is nothing but all words which are of the form of 1A followed by some number of B's, right? It can have maybe no B's at all, maybe no B's at all as well, like the first string which is represented a single A. Now here the language is given, and from the language we can define the regular expression of it. So what will be the regular expression for this particular language? We can write the regular expression for this language as, we know it's a single A and then any number of B's. So we can represent it like this, AB star, where B star is representing any number of B's starting from 0 to any length. So we can do it either ways. In this example, here the regular expression was given and we try to identify the language of what is this regular expression is representing. In the second example, we took the language and from the language we defined the regular expression. So in either ways we can do it. Let's take another example. If I have AB star, right? So what is this AB star representing? It will have strings of the form either lambda, since star is there. Then I can have AB. Then I can have AB, AB. Then I can have AB, AB, AB. Then I can have AB, AB, AB 4 times and so on. This is what the clean closure represents, right? Union of the strings of the form where the length of the n keeps on increasing by 1. So this is the string which is of length. If I consider this entire string as A, then A raised to the power n, where the power of n can be from 0 to any length. So this is what this regular expression is representing, right? So if I try to identify the language of this, the language will be strings of A's and B's which consist of the substring AB, right? So we can see here there is one substring of AB, here there are 2, here there are 3, here there will be 4, then 5, 6 and so on. Now the same language can be represented by different regular expressions, right? For example, if I have a language as X, double X, triple X, 4 times X and so on. So what is this language? This language is X raised to the power n, where n is starting from 1, not 0, 1, 2, 3 and so on. So if I have to represent this language as a regular expression, that what I can do? I can simply represent it like x plus, right? This is representing by this language only, no lambda should be there and x plus is representing this. Then there is another way to represent this language using another regular expression. I can also write it, right, like this, like 1x is fixed, right? And after that there can be any number of x's. Here there are 0 x's, here there is 1x, here there are 2x, here there are 3x. So I can also represent it like this, like the starting x is fixed and then x star is representing any number of x's starting from 0 to any length. So this is another way of representing this language. Then there can be another way of representing this language. I can use it x plus x star. X plus guarantees that one x is fixed and x star guarantees that any number of x's. Then I can also reverse these positions, which gives me another regular expression x star x plus. The idea is that the single x has to be mandatory because there is no lambda in it, and then any number of x's can be there. Then there can be another way to represent this. I can have 1x which is fixed then x star, x star. Similarly, you can increase it to any number of x star, x star, x star, x star, right? So the idea is that the same language can be represented with a number of different regular expressions, right? Let's take another example. Suppose my language is AA, ABA, ABBA, ABBA, A4 times BA, and so on. So what is this language representing? We can clearly see this language is representing all strings that should have at least 2 letters in them, right? And that 2 letters should be a starting A and ending A, followed by any number of B's in between, right? Here there is no B in between, here there is 1 B, here there are 2 B's, 3 B's, 4 B's, and so on. So can I represent this language with the help of a regular expression? It says that the starting A and the ending A is fixed, and in between there can be B's of any number. And whenever there is a word like this, that there can be B's of any number or A's can be of any number including 0, then that can be simply represented by B star, right? So this regular expression is representing this kind of language. Let's take another example. If I have A star, B star. So what is this representing? This is representing all strings of A's and B's, but the condition is where all A's, if there are any. Why we are using this word if there are any? Because of the star on the A. So all strings of A's and B's where all A's comes before all B's, right? Comes before all B's. So we can clearly see this. What kind of words will belong to this language? It can have lambda, it can have A, it can have a single B, it can have AAB, it can have, but it cannot have a word like this, AABA, because B should not be followed by any A. So this will not belong to this particular language, right? So from this we can say one thing, that if I write A star, B star, the regular expression that we just saw, and if I write AB star, so are these two regular expressions same? No, the two regular expressions are not same. This is representing all words of the form where all A's should come before all B's, right? Any number of A's, then B's in any number. But this is representing where AB substring should be there. It will have AB, then AB, then AB, then AB, and so on up to any number. So these two regular expressions are naturally different regular expressions. Let's take another example of regular expression. For example, if I write L as x raised to the power odd, right? So what does it say? That I have x's in odd numbers. I can have x, I can have then triple x, then x 5 times, then x 7 times, right? So this is my language. Now how to represent this language with the help of a regular expression? So I can write it like this. If I take this x as a common x, then the rest, whatever will be left now, will be an even number, right? So that can be represented as a pair like this, right? So single x can be represented by this, star can be taken as null, and we will get single x. Then if I take the value of star as 1, then I will get triple x. Of 2, then I will get 5 times x. Of 3, then I will get 7 times x. Or I can also represent it like this. Like this is in front if I reverse the positions. So both the two regular expressions are valid to represent this kind of language where the number of x's are odd. But if I try to write something like this, let's say x star, then x, then x star. So will this regular expression will be valid for this particular language? Let's check. If I take a single x from this x star, then this x is, we have to consider this because it's a valid substring. Then From this x star, let's say I consider two x's. Now this forms my even string and this is not belonging to my language. So we have to carefully check that what is the exact language, and according to that a regular expression will be framed from it. Now we have seen the positive closure. Similarly, in the plus sign, whenever used in a regular expression like this, if I say x plus y, this is my regular expression. So what does it say? It says x and y are strings of characters, then this expression means that either x or y. So this plus is representing or over here. Either take this x or take this y. Right? So let's understand this with the help of an example. If I write, let's say if my alphabet is A, B, C and my language is A, C, A, B, C, B, A double B, C double B, A triple B, C triple B, and so on. So first of all, whenever we have to write the regular expression, first we have to understand the language of it. So let's understand what does this language represent. It says A, C. Then A is followed by a B, C is also followed by a single B. A is followed by double B, C is also followed by double B. A followed by triple B, C is also followed by triple B. Now what does it indicate? It indicates that the strings must begin with either A or C followed by some number of B's in between. Right? This is what the language represents. All strings that either begin with A or C but with some number of B's in between. Okay? So how to represent it? We can represent it by using this plus sign over here. So to first let's represent the A string. So begin with the A followed by any number of B's. Can be represented like this, or begin with the C with any number of B's in after it, right? So can we club this and write A plus C B star? So this is the regular expression that this language is representing. Let's take another example. If I write my language is AAA, AAB, ABA, ABB, BAA, BAB, BBA, BBB. So this is a finite language. The language is finite. We have already seen that if the set consisting of the language is finite, then the language is finite, and if the set is infinite, then the language will be infinite. So here there are total 8 strings in the language, so we say it's a finite language. Now if I have to represent a regular expression for this particular language, what it will be? We can clearly see that this language consists of all strings of A's and B's which are of length 3, exactly 3 length, right? So we can say that at first position, let's check the first position. Here it is A, here it is also A, then B, 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 B. So 4 strings are starting with A, 4 strings are starting with B. So can we say that at first position we can have either A or B, right? Similarly, let's check the second position. The second position, A, then A. Then the rest of the strings have B at second position. 4 strings have A, 4 strings that have B. Then at second position also it can have A and B, and similarly goes for the third position. So this forms my regular expression for all strings that are of exactly 3 length where the alphabet is A or B. So similarly, if I have to form any fixed length string, I can easily form it with the help of this regular expression. So this can be expanded as A plus B to the power cube, right? This is representing the language of this set. Similarly, if I have to form a 7-letter string of A's and B's, this was a 3-letter string. If I have to form a 7-letter string of A's and B's, so what it will be? It can be represented like this, right? So this was for a fixed number. Here it is of length 3, here it is of length 7. If I have to form a generic regular expression that represents all strings of A's and B's, all possible strings of A's and B's, then we can use the regular expression this. So this star indicates every possible string of A's and B that can be formed from the alphabet consisting of A and B. So this is a very important regular expression which will be often used frequently to represent most of the strings. Let's take another example of a regular expression. If I have to represent all words that begin with letter A. So I have to represent all strings that are beginning with letter A. So if they are beginning with letter A, I can fix this position, and then after this A, there can be anything. There can be any number of A's, there can be any number of B's. So basically every possible string of A and B, and just now we have seen that to represent every possible string of A and B, we can use this regular expression. So this can be written as A followed by any string of A and B, A plus B star. So here it was beginning with letter A. If the question is all words that begin with letter A and end with B, so what I have to do? I just have to replace, or not replace, I just have to add a B at the end. So this will form all words that begin with letter A and are ending with letter B. And there can be anything in between, any possible string of A and B of any length. So all these regular expressions enumerate the words that are part of the language and they are called the regular expressions. And we have also seen that corresponding to every regular expression there is a language associated with it. Like this is the regular expression and this is the language associated with this particular regular expression. So the language that is associated with the regular expression is known as a regular language. So regular language is nothing but language associated with the regular expression. Language associated with a regular expression. So basically we can say that a regular language is the one that can be defined by any regular expression. So if corresponding to any language we can write a regular expression, we say that the language is regular language. A regular language. So we can also define it with another way. The regular language can also be defined as that whatever symbols that appear in regular expressions, they are nothing but the letters of the alphabet. This we have seen, letters of the alphabet, or the symbol for the null string, or parenthesis, or the star operator, or the plus sign. So these are the symbols that are allowed in my regular expression. They can be the letters of the alphabet, we have seen that. There can be lambda also in a regular expression, that is also valid. There can be parenthesis also, this is also valid. There can be star and there can be plus. So besides these symbols, there will be nothing that will be part of my regular expression. So regular expressions are also defined by certain rules which says, first we have rule 1. Rule 1 says that every letter of the alphabet, can be made into a regular expression. Lambda is also representing one regular expression. Rule 2 says that if R1 and R2 are two regular expressions, then this is also a regular expression. R1 concatenated with R2, this is also a regular expression. R1 plus R2, this is also a regular expression. And R1 star, this is also a regular expression, right? So if I say that A is my one regular expression, B is my another regular expression, then this is also a regular expression, R1 in R concatenated with R2. This is also a regular expression. A plus B. This is also a regular expression. And if I write A star, this is also a regular expression. And nothing else besides these will be counted as a regular expression. Rule 3 says nothing else is a regular expression besides these. So moving on with the regular expressions, let's take few more examples to understand regular expressions. If I take, like for example, A plus B star, A plus B star. So what is the language of this regular expression? Let's check. So here it says that the A in the mid, this A is mandatory. Now there can be anything over here and there can be anything over here. So one string that we can form from this is A. Let's say if I take this also lambda, this value also lambda and this value also lambda. So I'm left with a single A. So we can say what is the language of this? All strings of A's and B's that have A in them somewhere, right? That A can be at any position. If I take, let's say, string ABBA from this particular A plus B star, and if I take A, B, 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 B from this particular A plus B star, then this A, it can be at any position somewhere in your string, but the condition is one A has to be there, right? So this is the language that is associated with this particular regular expression. Now if I say that, will I be able to form a string BB from this regular expression? Can I form BB from this regular expression? No, because the language says that there has to be one A in between, that is mandatory, and BB does not contain that, so we say that BB cannot be formed from this regular expression. But if I have to form, let's say, any string of B, then I can use the regular expression B star, right? So this B star will guarantee that I can form any string of B's from my B star. So if I club these two both, let's say A plus B star, A plus B star plus B star. So what does this represent now? That any possible string of A and B can be formed from this, right? The only thing that was missing in this was strings of B's that we have added by accommodating this B star. So now we can say that any possible string of A's and B's can be formed from this regular expression. So from this we can say that, let's take one more question to come to one conclusion. Let's say if I write, construct a regular expression for a language of all words that have at least two ways. So it says language of all words that have at least two ways in it. So let's try to frame the regular expression. If I write, so they are saying that two A's should be there, but the position is not there mentioned in the equation. They can be at any position. So let's say one A is here, then there can be anything starting before this A, right? Similarly, there can be anything after this A, then another A that has to be mandatory, and there can be anything after this A as well, right? So this is optional, this is optional, this is option, and the strings, all strings we can form from this, and two A's are mandatory, which are at this position and at this position. So this is one of the regular expression for this language. I can have another regular expression for this language. Let's say if I say this A is mandatory and I can have any string of B before this. Similarly, I can have any string of B after this. Then another A, then A plus B star. Again, every possible string will be formed from this also, right? I can have any possible string from this also. Let's say if I try to rephrase the above regular expression and write it like this by interchanging the positions. A, then B star, then A, then B star. This is also one of the regular expression to represent two A's, at least two ways, and then anything in between, before it, after it, anything in the middle, that is a valid string of A and B. Let's say if I write B star, then A plus B star, then A plus B star. Again a valid string. These two A's are mandatory, and then anything can be before it and after it. So we can say that we have seen this in the previous example also, that a same language can be represented by a number of different regular expressions, right? So we say that all of these regular expressions, this 1, 2, 3 and 4, all of these regular expressions are equivalent. So when we say that the regular expressions are equivalent, we say that they describe the same language. So two regular expressions are equivalent when they define the same language. So this was all about today's lecture. In the upcoming video, we'll learn and practice more examples of regular expressions. If you like this video, then do like and share my video and subscribe my channel. Thank you.